Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3 for May, June 2024, and this is part 2 for questions 7 to 11. Question 7, let f of x equal to 8x cubed plus 54x squared minus 15. Question 7, let f of x is equal to 8x cubed plus 54x squared minus 17x minus 21, part A, show that x plus 7 is a factor of f of x. Now we are going to use the factor remainder theorem, which states that f of this negative 7 here is going to be equal to 0, okay? Why is it like that? If I have a polynomial here, and it is equal to a divisor, which is a function of x, then times the quotient. So the divisor, I can write it as, let me write it in this format here, that x may be minus a, okay? Then we have the quotient here of x, and then plus the remainder, okay? Now, when we multiply, when x is equal to a, this whole thing is going to go, and then you get a remainder of 0. Okay? That means when I put x is equal to a in the polynomial, I get the remainder. Okay? So this is what we call the factor remainder theorem. So meaning, if I put negative 7 in here, in other words, just get this one equated to 0, you get the value of x. Okay? So when you put it in here, do you get 0? That is the question, okay? So we are going to put f of negative 7. So we shall have 8 into negative 7 cubed, then plus 54. Then we have here x, which is negative 7 squared, then minus 17 times negative 7, and then minus 21, okay? So do we get 0 is the question. Okay, now let us just put this in the calculator. 8 into negative 7, then cubed, plus 54 into negative 7, then squared, minus 17 into negative 7, and then minus 21. It gives us a 0. So that means this one is a factor. Then part B, find a quotient when f of x is divided by x plus 7. There are two methods I can use here. One is long division, then the other one, we call it the synthetic approach, okay? So using long division, what do we have? Let me actually split it into two. I can have this one here. We have 8x cubed, then plus 54 x squared minus 17x, then minus 21. Our divisor is x plus 7. You just divide the first with the first, the rest you multiply. So 8x cubed divide by x, you get 8x squared. So we shall have here 8x squared. Now we can get this, multiply through. So we shall get here 8x cubed, and then plus 7 times 8, that one gives us 56. So 56x squared. Then when we subtract 54, of course this one disappears. Now 54 minus 56, that is a negative 2. So we shall have negative 2x squared. Then I can bring these ones down, negative 17x, then minus 21. Then negative 2x squared divided by x, you get negative 2x. So I'll put negative 2x here. Now this times this, so we shall get negative 2x squared, and then 7 times negative 2x, we shall get negative 14x. Then we can subtract negative 17, then minus 14. This one becomes a plus. So negative 14 plus 4, negative 17 plus 14, this one gives us a negative 3, okay? So we shall have here negative 3 of x, then now minus 21. So negative 3 of x divided by x, we shall get negative 3. So I'll write here negative 3. Then the whole of this times the negative 3, we shall get negative 3 of x, and then minus 21. When we subtract, we get a 0. Okay, so what remains here is actually the quotient. So we shall say that the quotient is equal to 8x squared minus 2x minus 3. Now, do you see that the remainder is 0 here? So it's the same thing that we got here when we substituted the x, which is equal to negative 7. So what you get after substituting is the remainder. Okay, alternatively, this is what you can also do. We call it the synthetic approach. I can write the coefficients of all these terms in the polynomial. So here I have 8, 54, negative 17, then negative 21. If we have something like 8x cubed, then the next one is, let's say, 54, then x, and there is no x squared. That means the coefficient of that x squared is going to be a 0. Okay, so you have to consider it there. Now, we are going to write these coefficients here. Write the 8, then 54, then negative 17, and then the other one is negative 21. Now, I'll put a line here, and then the divisor we are having, this one is applicable where the divisor is a monomial. What do I mean by a monomial? The power of x is a 1. Okay, you can have maybe 2x plus something. So long as the power of x is a 1, don't use it for quadratics or other higher powers. So in here, for x plus 7 being a factor, the x value here is a negative 7. Now slide this 8 down here and you write it. Then you say 8 times negative 7. You'll get negative 56, right? So we shall have negative 56. Now add these two. When you add them, you get negative 2. Then get this negative 2 times negative 7, you will get 14. So 14, you write it below this negative 17. Now add these two. When you add them, you get a negative 3, okay? Now negative 3 times negative 7, you will get positive 21. So you write it here. Then add these two, you get a 0. So always what you get here is a remainder. Is the remainder. Then this one here is the quotient. Okay, it contains the coefficients of the quotient. Now, since here we had 8x cubed, and then we are dividing by a monomial, the power reduces by 1. So that means this 8 here is the coefficient of x squared, then x, then now the constant. Okay, so from there, you just conclude that your quotient, the quotient is going to be equal to 8x squared minus 2x minus 3. As simple as that. Then part C, hence solve the equation, this one here. Now it is trigonometric. But if you check by comparing with the other one that we have had, it is just where x is, it is replaced by the cosine of x. So x is equal to the cosine of theta, not x, okay? So since we have gotten, the other one is x plus 7, then times the quotient, which we got as 8x squared minus 2x, then minus 3, okay? So this simply implies we shall have cos of theta, then plus 7, and then inside here 8 cos squared theta minus 2 cos theta minus 3, which is equal to 0. Okay, then we can factorize this one here by putting this in the, because it is a quadratic, by putting it in the calculator. What do we get? So go to your calculator, we go to equation, which is 5, then quadratic is 3. We can put 8, then negative 2, then we go to negative 3. So this one gives me 3 over 4, and then negative a half. So cos theta is equal to 3 over 4. Also cos theta is equal to negative a half. Now by putting this one back, because you have to show the examiner that you have solved the quadratic equation, it will be 4 cos theta, then bring the 3, okay? So we are going to have 4 cos of theta, then minus 3. And then here, when you cross multiply, you will get 2 cos theta. Then bring this one here. So it is 2 cos theta plus 1. So here I will have 2 cos of theta plus 1, which is equal to 0. And then here we also have the cosine of theta plus 7. That means I can put it here also, cos theta cos theta is going to be equal to a negative 7. Of course, this one is undefined because cosine ranges between 1 and negative 1. It doesn't go beyond this, okay? So when you get the arc cos of negative 7, it will give you math error. Now here, our theta is going to be the arc cos of 3/4. And also here, theta is going to be the arc cos of negative 1/2. So I'm going to draw my circle here. Okay, this is A, S, T, C. If this is 0, are we given the... Yes, it is in degrees. So we are going to consider degrees 0 degrees. Here 90 degrees, 180 degrees, 207. You can use this unit square or the 4 quadrants, or you can use the sketch. Okay, some people use the sketch, no problem. Now, if I project an angle here, let's say that is the theta, this is the theta, then also here theta, and then this is theta. So meaning to find an angle, remember when we go anti-clockwise, the angles are positive. So up to there, it will be 180 minus the theta. So this will be 180 here minus theta. This is 180 plus theta, because you are moving like this up to here. You see that? And then moving from here up to here, you just get this 360 minus this angle here. Okay? So we shall have here 360 minus theta. So we are using 180 and then 360 because these are angles on the horizontal. So for the angles, we look at the deviation of these angles from the horizontal axis. Okay. Now here arc cos of 3/4. So since this one is positive, we are going to go to the quadrants where cosine is positive, and cosine is positive in the first quadrant and fourth quadrant. So after getting the acute angle from here, we shall subtract it from 360. Okay. So since the answer, the domain is given in degrees, your calculator must be in degrees. Don't put your answer in radians. So shift, then cosine, we have 3/4. This one, what does it give us? This is 41.4. So if it is 41.4, then the other answer is going to be 360 minus 41.4. You see that? Then for this one here, I'm going to ignore the negative. We are supposed to pick angles from where cosine is negative. Okay? Cosine is negative here and here, in the second quadrant and third quadrant. So what you need to do is to first ignore the negative, then you get the arc cos of 1/2, which is 60 degrees. Okay, so then you go to the second quadrant where cosine is negative. So 180 minus that 60, and also 180 plus that 60 in the third quadrant. So we have 180 minus the 60, and then 180 plus the 60 degrees. So altogether, theta is going to be equal to 41.4 degrees. Okay. Then the next one, I'm writing them in ascending order. Okay. We shall have 180 minus 60. That one is going to be 120 degrees. And then 180 plus 60. That one is going to be 240 degrees. And then 360 minus 41.4, that one will give us 318.6. So these will be the answers that we are supposed to have here. Question 8, part A. Express 3 cos 2x minus root 3 sine 2x in the form r cos 2x plus alpha, where r is greater than 0, and then alpha is ranging between 0 and pi over 2. It's an acute angle. Give the exact values of r and alpha. Now here you don't have to waste your time. If you have 3, then cosine of 2x minus root of 3 sine of 2x. This one is going to be equal to r, then cosine of the 2x plus alpha. Now, the r is going to be the square root, okay, of the squares of these coefficients here of sine and cosine. So you will get the square root of 3 squared, then plus this root of 3, okay, squared. Then, whether you put the negative or no, that is the one. Then next, this is cosine. Then inside here, we are going to have the 2x, then plus this alpha here, okay, is the arctan of what is down in the denominator is the coefficient of the cosine. It's a 3. So I'll put the 3 here, and then here I'll put root of 3. Forget about this sign here because it is catered for in the expansion of this one here, because we know that for compound angles of cosine, cos of a plus b is the same as cos a cos b minus, okay, sine a sine b. So there is a minus here for this plus here, so it is catered for. You don't put that negative there. And then here we have 3 squared is a 9, and then the square of the root of 3 gives you a 3, so that one gives us 12. And root of 12 is the same as saying root of 4 times root of 3, which is 2 root 3, okay? So I'll write my r as 2 root of 3, and then the arc cosine of this is 2x. Root 3 over 3 is the same as 1 over root 3. So arctan of that is 30 degrees, okay? So that one has to be pi over 6 because they said alpha is in radians here, 0 to pi over 2. So I have to represent this one as in radians, okay? Just this one here is what you need. However, the long method that leads us to this one is this. If you can't memorize this one very fast, but you are going to do this, you expand. So cos 2x here minus root of 3, then sine of 2x. This one is going to be r. When you expand this using the double angle formula, you are going to have cosine of 2x, then cos alpha, then minus r sine 2x sine alpha, okay? Now we equate coefficients. Equate coefficients. The coefficients of, okay, of cos 2x, okay? Here it is a 3, so I'll write a 3. Then you cover this cos 2x here. You are going to get r cosine of alpha. So that one is going to be the coefficient of the cos 2x. So r cos alpha. And then for sine 2x, this one here is giving us negative root 3. And then this way, cover this one here, it is negative r sine alpha, okay? Negative r sine alpha. So do you see that the negative cancels? Okay, now we are having these two equations here. This is 1, this is 2. Then you can get equation 2 and then you divide it by equation 1, because we know that sine over cosine can give us a tan, okay? So this one is going to be equal to root of 3, then divide by 3. So this will be tan of alpha, which is equal to root 3 over 3. So meaning alpha is equal to the arctan of root of 3 over 3. So do you see that the coefficient, the denominator here is exactly what I told you here, is the 3, and it is the coefficient of the cosine you have here. So if here we had sine, then what would be down here would be the coefficient of sine here, as simple as that, okay? So getting back to this, by of course, getting the arctan of this, it will give you pi over 6 or 30 degrees. Then, if I get equation 1 and I square it, then plus equation 2, and I also square it, because I know cos squared plus sine squared gives us something, okay? So we are going to have 3 squared, then plus negative. It's not actually negative. The negative disappeared. So root of 3, then squared, is going to be equal to r squared cos squared alpha, then plus r squared sine squared alpha. You can see that r squared is common. Then inside here, I'll have cos squared alpha plus sine squared alpha. So which will be equal to, this one is 12. So in trigonometry, we know that this one is equal to 1, right? So meaning our r is going to be equal to the square root of 12. So r is therefore 2 root of 3. So you don't need to waste time with all of this. It is even just 3 marks. You just know that your r is the square root of the coefficient of cos squared plus the coefficient of sine squared, okay? And then the alpha here is the arctan of what have they told you to express your expression in. If it is cosine here, what will be in the denominator here of the arctan is going to be that coefficient of this cosine. If it is sine, then it will be for sine. As simple as that. Now part B, hence find the exact value of this integral here. So the hence, we are supposed to use what we have gotten, okay? So we are integrating from 0 to pi over 12, and then 3 over, this is 3 cosine of 2x, then minus the root of 3 sine 2x, then squared with respect to x. So this is going to be again the integral from 0 to pi over 12. This will be 3 over what we have gotten in the other previous one. I'm going to put it in the place of this, okay? And it is 2 root of 3, then the cosine of 2x, then minus, it was plus pi over 6. Now when we square, that means this one will be squared, and also the cos squared here will be squared. The cos will be squared. So this one, remember, is 12. So 3 over 12 will give us a quarter. So that a quarter, I can take it outside here. So I will have, this one is pi over 12, and then 0. Then 1 over cosine is the same as sec squared. So sec squared 2x, then plus pi over 6 dx. When we differentiate tan, we get sec squared. That means when we integrate tan, when we integrate sec squared, we get tan. So that means here I'll get tan of this angle 2x plus pi over 6, but I will divide by the derivative of this angle here, because this angle is not, the coefficient of x is not 1. So when you differentiate, you get that answer 2, but then you divide it. When it comes to integration, we divide it, okay? If it were differentiation, then we multiply it. So I will divide by that 2, which is the derivative of this angle. Then we shall put pi over 12 here, and then the 0. So by putting the limits, we shall have, in fact, let me take a half out. It will become 1 over 8 here. And then I can put tan of 2 pi over 12 plus pi over 6, then minus tan, this one will be pi over 6, because 0 cancels the other x that is there. And then what are we going to have here when this one is simplified? Okay, what are we going to have there? So let me just put everything in a calculator, we get the answer. So let me turn my calculator to radians. That is 4. Then now we say tan of pi over 6. Actually, this one is going to be 2 pi over 12 is going to be pi over 6. So pi over 6 plus pi over 6, that is pi over 3. So tan of pi over 3 is actually root 3. So inside here, I'll put root 3. And then this one is tan of 30 is root 3 over 3, or 1 over root 3. Now 1 minus a third, okay, because root 3 here is common. 1 minus a third, that one gives us 2/3, right? So that means we shall get 1 over 8 times 2/3 of root 3. So this 2 here can reduce the 8 to a 4, and then we shall have root of 3 over 12, because the 4 that is here, after this one has reduced in this, then times the 3. So our answer becomes that, and that is the exact one they needed. You're not supposed to put there your decimals, okay? They say the exact value, and that is that. Question 9. A container in the shape of a cuboid has a square base of side x and a height of 10 minus x. It is given that x varies with time t, where t is greater than 0. The container decreases in volume at a rate which is inversely proportional to t. When t is equal to 1 over 10, x is equal to 1 over 2, and the rate of decrease of x is 20 over 37. Part A, show that x and t satisfy the differential equation, this one here. Now, there is something they have said here, that the container decreases in volume. That means dv dt shall be equal to a negative value, okay? So we shall use a negative sign there. Now, we are told that the container decreases in volume at a rate inversely proportional to t. In IGCSE or in O-level, you used to do variation. So we shall have dv dt, which is inversely proportional to t. So it is 1 over t, okay? Now, by removing the proportionality sign, we put the proportionality constant. So this is dv dt, which is going to be equal to negative k over t, just like that, okay? Now, we know that volume of a cuboid is length times width times the height. So we shall get x times this times that, okay? So we need to get dv dx. Volume is going to be equal to x times x, that is x squared, then into 10 minus x. So when I open the brackets, this will be 10x squared, then minus x cubed. So meaning dv dx is going to be equal to 20x, then minus 3x squared, okay? So what do they want us to show? Dx dt. So how do we get dx dt? Dx dt using chain rule is going to be equal to dx. This x is connected to v, so I will say dv, then dv dt, okay? So that this one can cancel with this and you remain with your dx dt. Now, we have this dx dt, therefore equal to, if dv dx is this, then dx dv is going to be the reciprocal of that. So it will be 1 over 20x, then minus 3x squared. You see that? Then times, what will be our dv dt? dv dt is here. So it is times negative k over t. You see that? Then after that, we need to use the initial conditions which were given here. The initial conditions were t is equal to, they are here, there. So we are going to say dx dt, this one here is given as the rate of decrease of x. It is 20 over 37. So you have to put a negative there, okay? Because it is the rate of decrease. So the value has to be a negative here. When they are just saying it in the statement, they don't put there the negative. But when you are mathematically transforming it, it has to be with that negative value. So this one is equal to 1 out of x is 1 over 2. So 20 times 1 over 2, which will be 10. Then minus 3 times also 1 over 2 here, but squared. Then times this is negative k over t is 1 over 10. So this one will help us to get the value of k. Okay, so now taking all of this one here, this other side, actually this negative here is going to cancel with this one, okay, from there. So I can cross this with that, And then we have 20 over 37, which is going to be equal to, I'm going to get this whole thing here and I simplify it, okay? What do we get there? So it is k over what? I have 10. We have actually 10. Remember, 20 times a half is 10. Then minus, we have 3 into a half, which is 0.5, then squared. Then down, there is 10. I'm going to put this 10 because I have 1 over 10, okay? It is multiplying through. So we shall have a 10 here. So altogether, this one gives me 37 over 40. 37 over 40. So meaning k is going to be equal to, when you cross multiply, you will have 20 over 37, then times 37 over 40. So of course this one will go, and then 20 goes into 40 two times. So our k is going to be equal to a half. Okay, so this therefore implies that our dx dt is going to be equal to, we substitute here. So it is 1 out of 20 of x, then minus 3x squared, then times k is negative a half, so we shall put negative 1, then over 2t. So it will be that here. Actually, it is the same as what they have told us to show. Do you see this one here? Negative 1, then 2t here. It is exactly this one that we are having here. 2t times whatever is here, then 1 times the negative 1. So we already have the answer. Part B, solve the differential equation obtaining an expression for t in terms of x. So we have so the first thing to do is to separate variables. Okay, separating variables, you put x's on one side, and then you put the t's also on one side. So this is our differential equation here. To separate the variables, I will just cross multiply. So this part here will have to come here, and then it multiplies with the dx, and then the t to multiply with this negative 1 over 2t. Okay, so I'm going to have 20 of x, then minus 3x squared. This one is multiplying with the dx, and then this way we have negative 1 over 2t multiplying with the dt. Okay, now we can integrate both sides. Separating variables carries a mark. Okay, integrating, what does it give us? Integrate 20x, then minus 3x squared with respect to x. This one will be, I'll put the negative a half out, and then I say 1 over t here. Since when I differentiate the denominator, I get exactly what is here with respect to t, so that will be a natural log. So here I'll get a half, then the natural log of t, plus a constant, which the constant we don't know because we don't have the limits. This is what we call indefinite integrals. Okay, so we have to put that c there, and then we use the initial conditions to find it. Okay, so when you integrate this one, you are going to increase the power by 1, so it is 20x squared over 2, which becomes 10x squared. And then this one here is 3x cubed over 3. So the 3 cancels. That means we are going to have x cubed here. So just like that. Now remember, we were given t, which is equal to 1 over 10, and also x being equal to a half. Okay, so put 10 here, your a half, and then also here a half, then cubed. This one is going to be equal to negative a half, then natural log of 1 over 10, then plus c. So meaning our c can come this side, and then we have the whole of this. When we put in the calculator, what we get simplified? 10 into 0.5 squared. This is 0.5, not 25. Then minus 0.5 cubed. So it is 19 over 8. So I'll write here 19 over 8, then plus a half. Natural log of 10 is the same as, 1 over 10 is the same as 10. This one will be power negative 1, okay? So this one will give us the value of C. So using the rules of logarithms, of course, I can drop this one here, and then it makes this whole thing a negative, okay? So C is going to be 19 over 8 minus a half the natural log of 10, okay? Then from there, that means our particular solution, when we have this C here, it is called the general solution, okay? Now, after finding the arbitrary constant, it becomes the particular solution. So this means that we have 10x squared minus x cubed, which is equal to negative a half, then the natural log of t, and then plus 19 over 8 minus the natural log of 10, okay? This one here is the value of C. Now, they told us to express t in terms of x. So we make t the subject of the formula. So I can put these two that have gotten natural logs together. So by factorizing out the a half, negative a half actually, I'll have natural log of t, then plus the natural log of 10, like that, okay? Then I can actually bring this 19 over 8, this other side can become a negative. And then here we have negative a half, then the natural log. Of course, this is addition, so we multiply the powers. Here I can have 10t, okay? And then after that, I can multiply all through by that 2 there, okay? We can multiply all through by negative 2. By negative 2, such that we take this one away from this side, okay? So here we shall have negative 20x squared. This is positive 2x cubed, okay? Then we shall also have, when you multiply this one by negative 2, the 2 will reduce this one to a 4, so it will be a positive, 19 over 4. Then this side, of course, we shall have natural log of 10t, okay? Meaning, remember, we have a rule in logarithms that if you have log ab, which is equal to c, then a power c is equal to b, okay? A power c is equal to b. So meaning, and you know that natural log is log base e. So I will have 10t, which is equivalent to e to the power of 2x cubed minus 20x squared plus 19 over 4. And then how do we get t from here? We divide all through by 10. So it will be 1 over 10 of e to the power of 2x cubed minus 20x squared plus 19 over 4. And this is not the only expression that you can get. There are many expressions that you can get from here. Remember here, I turned this one into this, so somebody can continue with this natural log. Somebody can continue with the natural log of 1 over 10, okay? So there are many ways, but this is what I came up with, okay? So that is that. Question 10, the equations of the two straight lines are given here, where a is a constant. Given that the acute angle between the directions of these two lines is pi over 4, find the possible values of a. So here we are using the scalar product. So d1, or the direction vector of this first one, you just look at what is in brackets here. So that is 3, 4, and a. Then the direction vector of the second one is here, which is negative 1, 2, and 2. So we are going to have d, the direction vector of the first one, we dot it with the second one here. Then it is equal to the modulus of the direction vector of the first one times the modulus of the direction vector of the second one, then cosine of the angle in between them. This is what we call the scalar product. Okay, So we are using the scalar product. Now, we are going to have 3, 4a, then dot it with -1, 2, 2. And then this side, the square root of 3 squared plus 4 squared plus a squared. Then times the square root of -1 squared plus 2 squared plus 2 squared. Then cosine of the angle in between them is given as pi over 4. To avoid making mistakes for such negatives, always put them in brackets, okay? Because when you put this one, even in a calculator, when you just put -1 and then you square, the calculator will just square this one, and then it gives you a wrong answer. Now, you just multiply this with this with that, and that with that, then you add all of them together. So this will be -3, then plus 8, then plus 2a. And then here we have 9 plus 16. That one will give us 25. So we shall have the square root of 25 plus a squared, then times. Here, this will be the square root of, this is 4 plus 4, that is 8, plus 1, 9. Square root of 9, that one has to be a 3, so 3. And then cos of pi over 4 is root 2 over 2. Or I can write it as 1 over root 2, okay? All works. Now here we shall have 2a, then plus 5. So I can cross multiply, okay, times the 2. Then is going to be equal to 3 root of 2, then times the square root of 25, then plus a squared. Now we can say square both sides. To eliminate these square roots, square both sides. So when we square both sides, first make this one go inside here. So we shall have 4a plus 10, okay? 4a plus 10. Then we can square that. And then when we square this one here, times also square root of 25 plus a squared, also squared. This whole thing is now going to be 16a squared, then 2 times 4, that is 8, then times 10, that will give us 80 of a, and then square the 10, you'll get 100. Then when you come to this square 3, you get 9. Then 9 times 2, you'll get 18. And then here you'll get 25 plus a squared, okay? Now, when we open the brackets here, on the right, we shall get 25 times 18. 25 times 18. That one is 450. So we have 450, then plus the 18 a squared. I can take everything this side. Okay, so 18a squared minus 16a squared. This one will give us 2a squared. Then minus the 8a. And then 450 minus 100, that one will give us negative 350, which is equal to 0. I can even divide all through by 2. And then this one will actually give us here a squared, then minus 40a, and then plus 175. Is it a plus or a minus? It will be actually a plus because 450 is bigger than 100. So plus 175, which is equal to 0. So put in the calculator, you get the answers. So we shall go to equation, which is 5, then 3 is quadratic, so 1, then we have negative 40, and then we have positive 175. And then it's a 35, and then 5. But remember, you have to show the examiner that you have solved the equation. So this is a minus 5, and then a minus 35. Then you can smartly write your answer that a is equal to 5, or a can be equal to 35. They actually told us that you find the possible values, so it is not one value. So it is that they are 5 and 35. So they are saying that part B, given instead that the lines intersect, find the value of a and the position vector of the point of intersection. So if the two intersect, then we are supposed to equate the x coordinates, the y coordinates, and the z coordinates. Now we have what we call the parametric equations of these lines. So let's check them and then we find them out. The parametric equations will be like, for this one, it will be I, so that is 1, then plus 3 lambda, because you multiply here. Then here there is j, so 1, then plus 4 lambda. And then this is 2a, and then this is a lambda. So 2a, then plus a lambda, okay? So something like that. And the same thing we do to this one here. So this is what we are going to have here. When I come back, I'm going to write 1 plus 3 lambda, and then 1 plus 4 lambda, and then 2a plus a lambda. This one here is going to be equal to, at the point of intersection, so negative 3 minus mu, and then negative 1 plus 2 mu, then 4 plus 2 mu, okay? Now, we can equate these ones here, and we say 1 plus 3 lambda is going to be equal to negative 3 minus mu, okay? So, and I can also have 1 plus 4 lambda, which is equal to negative 1 plus 2 mu. Then I can multiply this one by 2 and then this one by 1, such that I can eliminate the mu. In other words, these are two simultaneous equations, so you solve them, okay? So we shall have 2 then plus 6 lambda, which is going to be equal to negative 6 minus 2 mu, and then 1 plus 4 lambda, which is equal to negative 1 plus 2 mu. Now, when I add these ones, automatically this one will go, and then we have 3 here, then plus 10 lambda, which is equal to negative 7. So take this one this side, it will be a negative. So 10 lambda will be equal to negative 10, because negative 7 minus 3, that's negative 10. And then lambda is going to be equal to negative 1 when you divide all through by 10. Since I have the value of lambda, I need the value of mu, and then I equate these two to find a. Now, I can use any of these two equations I've used to get the value of mu. So I can say maybe 1 plus 3 lambda is equal to negative 3 minus mu. Okay, this is 1 plus 3 times negative 1, then plus this 3 here, then is equal to negative mu. So this one will go, and then you will have negative mu is equal to 1. So meaning mu is also going to be equal to negative 1. Now, I can use the third one. Since they intersect, that means the third equation must also be satisfied. So 2a then plus a times lambda is a negative 1, has to be equal to 4, then plus 2 times mu is negative 1. So here we shall have 2a minus a, that one will be an a, and then 4 minus 2, that will be a 2. So a is equal to 2. And then the position vector of the point of intersection, let me call it OP. If the point of intersection is P, then the position vector, I can use any of the two. I can use negative 3, negative 1, 4, negative 3, negative 1, and 4. And then there is minus mu. So minus mu is negative 1, okay? And then plus 2, then negative 1, and then plus 2, again negative 1. So what can we have from here? We can see that, of course, this will be negative 3, then plus 1, which will be a negative 2, not so? So that's a negative 2 that I will write here. And then here, negative 1 minus 2, that will be a negative 3. And then 4 minus 2, that one will give us a 2. Okay? So you can write your answer like this, or you can say OP is equal to negative 2i, then minus 3j, then plus 2k. Okay, or you can actually use this other one here. Okay, you can use this one here. So 1 plus 3 lambda. In the exam, you don't do this. I'm just showing each and everything. 1 plus 3 lambda is negative 1. Okay, then we have 1 plus 4 lambda. 1 plus 4 lambda. And then we also have 2a plus a lambda. 2a is 2, then plus a lambda is negative 1. Okay, so that is our OP. So what are we going to have here? This will be a negative 2, this will be a negative 3, and then, remember, our a is a 2, so let me also put it here. So 4 minus 2, that is a 2. So it's the same thing. So whether you use this one or this one, you get the same answer since they intersect. Okay, then this is the last number, 9 marks. Okay, use substitution. 2x is equal to tan theta to find the exact value of that integral there. So we are using integration by substitution. Now we have 2x, which is equal to tan theta. So since they have given you another variable, you have to also change the x in terms of the new variable. So when I differentiate both sides, I'm going to have this 2x here differentiated. Okay, I will differentiate everything with respect to x. So this one will be, you'll have to differentiate this one here with respect to x. It's like I've done nothing because this one can cross with that. Okay, now when I'm differentiating this, because this is implicit differentiation, I will differentiate tan theta with respect to theta. Then after I multiply by the theta, then dx. So it's like this one is going to cancel so that I remain with d tan theta dx. You see that? So that is what we call implicit differentiation. So here I'll get a 2. When you differentiate tan, you get sec squared theta. Then we put the theta dx. Okay, but we know that we can also change our variables here. I mean the limits. If x is equal to 0, then what is theta? Theta is going to be the arctan of 2x. Okay, arctan of this one here. So the arctan of 0, automatically that one is going to give us a 0. If x is equal to a half, because these are the limits we are given, so theta is going to be the arctan of 2 times a half, which is 1. So that one will give us pi over 4. Okay, so that is that. Now, when we come to our integration here, okay, we are going to have sec squared here is the same as 1 plus tan squared. So I can have 2. In fact, make dx the subject of the formula. So dx is going to be equal to, when you cross multiply, so it will be sec squared theta over 2. Okay, d theta. Now, sec, like I've said, is equivalent to 1 plus tan squared theta, then divide by 2 here, d theta. But do you realize that tan theta is 2x? That means when I square here, it is going to become 1 plus 4x squared over 2 of d theta. So meaning my integral from 0 to a half is going to be of 12 into 1 plus 4x squared, then squared dx is going to be now the integral from 0 to pi over 4, even the limits have changed, and then 12, then divide by This is 1 plus 4x squared. Now 1 plus 4x squared, we have seen it here. This one is the same as sec squared xc. Okay, so I can just write, instead of writing this 1 plus 4x squared, I will just put sec squared theta. Okay, but it is squared here, so I will put that square there. You see that? Okay, then next I'll say times. Now our dx here is sec squared theta d theta over 2. So this sec squared here will cancel one sec squared down here. And this 2, of course, goes into 12 6 times, right? So we shall get even the 6. I can put it just outside there. 0 pi over 4. And then we have 1 over sec squared theta d theta. If 1 over cosine squared of theta is equal to sec squared theta, that means 1 over sec squared theta. When you do the reciprocal of this one, it is the one that will give us cos squared what? Theta. That means we shall have 6, the integral from 0 to pi over 4, and then you have cos squared theta d theta. Okay, now this is why they gave you these 9 marks, because again we have to continue. If you get an even power of sine or cosine, you have to use the double angle for cosine. We have cosine of 2 theta, which is equivalent to, in terms of cosine, it is 2 cos squared theta minus 1. This one is in your list of formulae. So meaning, when I make this cos squared the subject of the formula, first bring this one here, then after you divide by 2. So it means that cos squared theta is going to be equal to 1 plus the cos 2 theta, then divided by 2. So this is what I'm going to substitute in here. 0 pi over 4, and then 1 plus cos 2 theta d theta, divide by 2. So I can take this a half outside here. It multiplies with that 6, and then we get 3 here. Okay, then the integral pi over 4, then 0, 1 plus cosine of 2 theta d theta. And then now we can integrate. When you integrate 1 with respect to theta, you'll get a theta. When you integrate cosine with respect to theta, you'll get a sine theta. So we shall get sine 2. But then we get this angle, we differentiate it, and then we divide it in here. For integration, we divide. For differentiation, we multiply it all through. Then this is pi over 4, and then 0. Now putting these limits here, we shall have pi over 4, then plus sine of 2 pi over 4, then divide by 2 here. Then after, we shall subtract. Of course, when we put 0, everything is going to be 0 here. Okay? Then this will be 3 pi over 4. You see that? When it multiplies here. And then 45 times 2, that is 90. Sine of 90 is 1. So we shall have this 3 here multiplying with a half. So if we check the format, they told us to express our answer in, it is here. It is A, then plus B pi. A plus B pi. So that means our A is 3 over 2. Then B is 3 over 4. Then the pi here. So that is that. So this has been it for this last part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.